Okay. Today we'll start on page 416.
Okay. Ow.
Hi, Cedric. Hey, Cedric, you have to go to Mrs. Lewis's class.
Oh, okay.
Okay? Tell Dante to go with you.
Oh, he's not here.
He's not here?
Yeah, my dad's picking up Dante from my mom's house.
Oh, okay.
Oh, and okay, they're back now.
Perfect. It's
They're
just
back.
the time
Just
for the math
now.
class.
Hey,
Okay.
Dante. Oh, we have to go to Mrs. Lewis's class.
Okay. Have a good day, Cedric. All right, guys, we're on 416. And this is the part where our books are a little bit off. So what does your book say, Serena, on page 416? What's the top of it?
Reading startup.
Okay. Okay. So we're doing a little bit of vocab on this page. And the first shape they show us is a parallelogram. And the formula for that one, Matthew, what did you put on the line? Area equals base times...
height.
Yes, good job. Okay, and the next one is a triangle. Area equals 1/2 times blank times height. Nathan, what do you have for that one?
Base.
Yes, base. Very good. Okay, so you guys remembered those formulas. And we have a little bit of new vocabulary. The first one says, the total area of all the faces of a three-dimensional figure is called the blank. Nicholas Willoughby, what do you got?
What?
What do you have?
Oh, I put surface area.
Very good. Surface area. That's it. Number 2, a model that looks like an unfolded three-dimensional figure is a blank. Nicholas Marks.
Annette.
Yes, good. And the last one, Serena, a three-dimensional shape with a polygon for a base and triangles for sides is a?
Pyramid.
Excellent. Okay, good job. Under that, does it say active reading? Is that okay? So we don't do that part. All right. Next page hopefully says, "Are you ready?"
Yes, it does.
Okay. Number 1, Serena. This was some evaluating with parentheses. What do you got for number 1?
18.
Yes, good. Number 2, Cassie.
Number 2.
Yeah.
225.
That's it. 3, Matthew. I think you're muted, Matthew.
Sorry, I thought you said Serena.
Oh, no, 3, Matthew.
Okay. I forgot to do this page, but I did the other page.
Okay. It is 65 for that one. You guys should have 65 for number 3. Number 4, Nathan.
Sorry.
Okay.
4.83.
I have double that for some reason, but it could be wrong.
Yeah, I have half of everything.
All right, so I'm going to do 3.5 plus 5.7, and I got 9.2 times 2.1 divided by 2. 9.66.
That's what I got.
I don't know if you divided by 4, Nathan, or divided by 2 twice. I'm not sure what happened.
Oh, I went 1/2 with everything.
Oh, I know you're probably thinking of like distributing, but you don't have to distribute because, well, the 3.5 and 5.7, you just put those together. And then then that's one term. And then you just have three terms, 1/2 times 2.1 times that last term. So you just have to divide by 2 one time. Okay. Number 5, Nicholas Willoughby. A triangle with a base of 6 and a height of 3. What would the area be?
9.
Good. And what did you put for the units, Nicholas?
Square inches.
Good. And number 6, Nicholas Marks. A square with a side of 7.6. What would the area be?
30.4 square meters.
I think maybe you did perimeter.
Oh.
Where you add up all the sides, but they wanted area. So you have to do length times width, or side squared for a square. So for that one, you should have 57.76 square meters.
Okay.
Okay. Do 7.6 times 7.6. Number 7, a rectangle with a length of 3 1/4 and a width of 2.5. Serena, what do you have?
Which number?
This is 7.
Okay. 5.75.
Did you do length times width?
Yeah. Okay then.
All right. 3 1/4 times 2.5. All right. So you should be doing 3 1/4 times 2.5, and you'd be like, oh no, I can't multiply till I turn them into improper fractions. So then you have 13/4 times 5/2. And nothing we can reduce, so 65/8 or 8 1/8 square feet. So you should have 8 1/8. There's the work for that. In number 8, Cassie, you have a triangle with a base of 8.2 and a height of 5.1.
Okay. Can I say something about number 7 quick?
Sure.
I actually I didn't turn them into improper fractions. I did actually turn them into decimals and then changed it into fractions, which and then I changed the final answer into a fraction and got the same answer. So you can do it either way.
Yep, that's true. You could do 3.25 times 2.5. Yeah.
Sorry, I just wanted to.
Oh, that's all right. Thank you. All right. What did you get for 8, Cassie?
20.91 centimeters squared.
Excellent. Good job. Okay. All right. So that's a little bit of getting us ready. We're going to talk today about nets and surface area. And we're going to start on page 420. There's a couple of definitions there I want you to read for surface area and pyramid. And I have to send, my daughter's just starting a new job today, and I have to send her social security number. So I'll be back. Just give me 1 minute. Go ahead and read about surface area and pyramid. And I'll be back in this. I'll be back for 1 second.
Okay.
Okay. So, I'm back. Surface area of a three-dimensional figure is the sum of the area of its faces. So when you're finding surface area, they say a net can be helpful. And the net is like if you were to unfold it and look at all the pieces that make it the shape. The net. You guys have drawn nets in our simple solutions. If we're talking about a pyramid, it's a three-dimensional figure whose base is a polygon, and whose other faces are triangles. So that was in our warm-up today. A pyramid is identified by the shape of its base. Okay, so if it's a square pyramid, the base is a square. Okay. So I want us to look at example 1. It says make a net of this square pyramid. So they drew the square base, and then since it's a pyramid, all the sides are triangles. So the net would look like this. Square is a base, and a square has 4 sides, so each of the sides would be triangles, so there would be 4 triangles. So if we wanted to find the surface area, we have to find the area of the square, and then the area of one of the triangles. And then all the triangles areas will be the same, so we add them all together. Okay, so let's try number 4, where it says use a net to find the surface area of this pyramid. So if we look at that and we want to use a net, it looks like we have a square base. Okay, we have a square base where it's like 16 by 16. And then every one of the sides is a triangle. Okay, so it would look like the one above it. And it's telling us that the height of the triangle is 20. Okay, so if we want to solve this, we have to let's find the area of this square base first. Nathan, how can I find the area of the square base? What should I do? Oh no, we lost Nathan. Okay, Nicholas Marks, how do we find the area of that square base?
When you multiply 16 by 16, I mean 16 4 times, or 16 by 16, yeah.
Just 16 by 16, yeah. And that gives us 256. So I'm going to write that inside my square. And you guys draw that in your book also, okay, where you're working on that. Draw the net, and then in the square base, write 256. Now we need to find the area of one of the triangles. Nicholas Willoughby, how can I find the area of a triangle that they gave us? What's the formula for area of a triangle, Nicholas?
1/2 times base times height.
Okay, 1/2 times the base. So the base is 16, Nicholas. What's half of 16?
8.
8. And how tall is the height?
What? Oh, 17. 17.
But look at the one we're working on at number 4. The height's different for that one.
Oh, yeah, sorry. 20.
20. So 1/2 of 16 is 8. 8 times 20 is how much?
160?
Yeah. So each of the triangles is 160. So to find the surface area, we have to add that all together. The 256 and the 160, the 160, the 1. So let's do 160 times 4. Okay, 160 times 4. And that gives us 640. And then we have to add the 256. All right. So you have to put all those areas together. Each of the triangles is 160. So 160 times 4 will give you 640. And add the 256 that Nicholas M. told us was in the base. Put it together, and you get 896 square inches. Are you guys okay with that? Okay, good. All right, let's look on page 421. They talk about the surface area of a prism. A prism and a pyramid are 2 different things. So think about, you're going to have to get these definitions in your head. A pyramid has faces that are triangles, okay? And picture pyramids from Egypt or something, and you know they always go up like in a triangle shape, those faces. A prism is a 3D figure with 2 identical and parallel bases that are polygons, and the other faces are rectangles. So just like the pyramid, the bases are polygons. They both say that. Base is a polygon. the prism has two bases that are polygons, and then the other faces are rectangles. You identify the prism by the shape of its base. Okay, so you do the same thing when you try to find the surface area, is try to think of it as a net, and you're finding the area of all of the surfaces. Let's try the number 6 at the top of page 422. It says, the figure shown is a triangular prism. Remember, they said that it's identified by the shape of its base. So the bases are triangles. So it's a prism, but it is a triangular prism. Its bases are triangles. Okay. How much would it cost to cover the bases and the other 3 faces with foil that costs 22 cents per square foot? So we have to find the surface area, and then we have to figure out, multiply that by 22 cents per square foot. Okay. So this triangular prism is going to be made up of 2 triangles, okay, like a top and a bottom triangle, and then it has 3 rectangles as the faces. Okay. The rectangles, the rectangles are kind of neat. I can see this rectangle on the bottom that's 5 feet by 2 feet. Do you guys see that? Kind of the bottom of the triangle. It's like right closest to us as we're looking at the book. There's a triangle that's 5 feet by 2 feet. All right, so if I do that.
There's one 6 feet by 10 feet. I mean 6 inches by 10 inches.
I might be looking. I'm looking at a different one, Nicholas. Look way at the top of that page. It looks like a triangular prism at the top where it says your turn number 6.
Mm-hmm.
You guys have that same thing in your book?
Yeah.
All right. So we got to figure out. Let's figure out how big the rectangles are. We have a 2 by 5 rectangle. And it looks like we have a 3 by 2 rectangle. And maybe a 4 by 2 rectangle. This one looks kind of tricky. Remember, these ones aren't Mrs. Palmer's favorite. Okay. So let's try to figure that out. Okay. So one rectangle is 10. One is 6 for the area, and the other one looks like it is 8. Add those all up, and we have 24. But we also have 2 triangles. And the 2 triangles should be, they're the bases. They should be the same. So we have to do 1/2 times base times height. The base of the triangle looks to be 5 feet. And the height looks like it's that piece going up that is 2.
I thought the 2 was the side of the piece. I think the part that goes up is the 3.
The 3. Base.
You could use the so there's a face that's 2 feet long. You could use that for the base, and then the 4 foot long measure for the height.
Well, remember the height, though, is not like a side of the triangle. It's always that piece that comes down and meets it at a 90-degree angle. They do show a 90-degree angle there. Use that for the height, the 4 and the 3. Okay. That does meet it at the 90-degree angle. Let's try that one. I like that. 1/2 times 4 times 3. I like it, Nathan. Okay. So that makes each one of the triangles surface area is 6. Okay, and we have 2 triangles, so that's going to be 12. And if we add that to the 24 we already have, it looks like our surface area is 36 square feet. And if the foil costs 22 cents a square foot, we have to multiply that 36 times 22 cents. Okay, so you guys will need your calculator for that. Well, I mean, you don't need your calculator. You could multiply 36 times 22 cents, but you're allowed to use your calculator. Maybe I'll just multiply it out by hand just for fun.
May I say the answer?
Nicholas March, you have the answer?
Yes, I do.
All right, what do you got?
I have $7.92.
That's it. I did it by hand and got the same. Okay, 36 times 22 cents a square foot, $7.92. Okay, so what I want you to work on for tomorrow is page 422, numbers 1 to 3. All right, and 3 has an A, B, and a C. So you have to, for number 1, they want to know how many square bases and how many triangular faces. And then 2, you're finding the area of the base and each of the faces and adding them together. And part 3, you're going to find the surface area of the box. And then the surface area of 100 boxes. And if 1 can of paint will cover 14,000 square inches, how many cans of paint would you need? Okay, you can cross off 4 at the bottom. You don't have to do that one. But on the next page, I want you to do number 5. It says use a net to find the surface area of that cereal box.
So we could cross off 4.
Yes.
Okay.
Yep. So you're going to do 1, 2, and 3, A, B, and C, and you can cross off 4. But I want you to turn, well, look at the next page and do number 5.
Okay.
Okay.
Is that all?
That's it. And then tomorrow we'll go over those and we'll try a couple more like that, and we'll move on to volume.
Mrs. Palmer, I will not be here tomorrow. So is there homework you want me to do tonight for that too also?
Well, I mean, you could still work tomorrow, right? Like while you're at your grandma's?
No.
You can't take your math book with you?
I mean, I could, yeah, but it's just she has internet that's kind of bad. So
yeah. It's okay if you won't be in class, but I'm just saying you don't have to do the book work tonight. You could take your book with you and do it tomorrow if you didn't get it all done tonight.
No. I was saying the pages that we're going to do tomorrow for homework.
Yeah. So tomorrow we're in class and for homework 427.
Give me a sec.
Hold on. I need to write this down somewhere.
Oh, yeah. You won't have to write it down, Cassie, because you'll be in class tomorrow. You just have to do today's. Okay? So, Nicholas, 427 and 428 and 429. 427 to 429.
Okay. Is there anything that's crossed off or anything?
No.
Okay. So just
okay.
Mm-hmm.
All right. Okay. If
Bye.
you guys have questions, you can come see me from 2 to 3.
Okay.
Have a good day.
You too. Bye.
I actually have a question right now.
Yeah, go ahead, Nicholas.
So do you think that we'll complete this? Because next week on Thursday is our last day. So do you think we'll complete the book?
I'm hoping, because this module only has 3 lessons in it, so I'm hoping to finish it this week. And then we'll go back next week to module 14. That's why I'm not taking time to do the assessments, and I'm doing the assessments just sort of during class time, because I think we'll be able to get the rest of the book in, and you'll be able to hit all of the concepts, at least look at them, you know, and be familiar with them.
Bye.
Thanks.
Bye.